Coast as well. Thank you for taking the time to log in today. I definitely appreciate it. As we go through the presentation, I'll give you a bit of a roadmap so you can see where we're going to be moving along. And of course, there's a chat bar on the side. If you have questions, feel free to type in your question on the side. And it may be that through the presentation, we'll address it on the way. And if not, when we get to the end, we'll fill out some time for questions and answers as well. As everyone comes into the room, we have everyone muted so that we don't have a large amount of audio feedback coming from the back. So all questions we'll be doing through the chat. And of course, if we don't have an opportunity for that today, you can always contact us. I'll have my email address at the end and the phone number for our headquarters in Michigan. So let's get moving along with Photometry 101 today. Myself, I have been with Lumicon for coming up on 11 years now. I grew up in Metro Detroit, like a large number of the Lumicon staff. And I got my master's in landscape architecture from the University of Michigan. And shortly after I graduated, I got on board with Lumicon and started photometric analysis. There's actually a lot of overlap between the two disciplines. It's all about spatial environment, figure-ground relationship, how an individual will move through a space, perceive that space, and of course, most importantly, how you can enhance safety throughout an environment. So coming on board, it was a very streamlined process getting into the world of lighting. Here's an example of some of the abilities that we have with current lighting software. This was a project that we looked at. They had tried several lighting solutions, and we were able to go through and do a full analysis and create a rendered animation to really flesh out and give a very strong idea to the end users of what their space would look like when it was completed. So that roadmap, as I mentioned, I broke this down into 3 sections for you. We're going to start out the presentation today talking about the control of LEDs. Not only do they have a great efficacy, but we really have an enhanced ability to point the light where we want it to be. We're also going to spend some time talking about the clarity of light from LED and specifically the quality of light, how that is perceived and used by a human observer. And then at the end, we're going to talk about confirming, really getting into how lighting software can be used on the front end of a project to specify, make sure you're using the best luminaire for your project that gives an overall aesthetic ability to perceive objects in a manner of safety, and also how all this can be done on the front end without cost or commitment. Let's start out looking at the control of LEDs. Here's an example of the energy wavelengths coming from the sun. And of course, there is some spillover. The visible light that you see is between 400 and 700 nanometers, but also light coming out of that source is going to be ultraviolet and infrared. You get those certainly from incandescent bulbs and also traditional HID forms. And that's just energy that can't be used as far as light. Now, analogous to that kind of spillover is when you take a traditional lamp, whether it's got a filament on the inside like an incandescent or you have some gases like HID, when that lamp is illuminated, of course the photons of light go in every single direction all the way around from that point source. And if you want to use this in an applicable situation where, for example, outdoor lighting, you want to point the light down, if it's going to be a roadway or a parking lot, you have to harness and redirect all of those upward lumens. That's going to be done with a housing, and inside they have to have a special reflector. And of course, you want that to be really specular, very much like a mirror surface, to reflect as much light as possible. Now, an important point about this is that whenever wavelengths of light interact with a physical surface, some portion of them, that energy, will be absorbed by the physical surface, no matter how mirror-like that is. And so if you look at a cut sheet for some HID sources, you'll see that when the light's being redirected, that's not accounted for. It'll be rated at, say, 28,000 lumens. But you're going to have between 20 to 30% light loss as it absorbs, and it's only accounting, that rating is only accounting for the lamp itself. The actual delivered lumens on day one are going to be substantially less. And so this is an important thing if we're looking at apples to oranges in comparison with traditional to current forms of technology. The solid state semiconductor, light, of course, you have a substrate with material where the LED is on the backing, and the light is all projected forward. Now, most encapsulant lenses have a range of 180 degrees beam spread. Now, of course, we have a lot of variety with that. We're certainly proud to use 20-degree beam spreads for flag lighters to really harness that in a direction. Now, of course, sometimes you also need to have light in a wider spread. We have options that we can do right from the point source of the illumination. And so with optics, what we can do is actually point where we're putting the individual portions of light and get a smooth illumination across the surface. We have a lot more control than just shoving and blocking the light around with reflectors, which are also, of course, absorbing some of that light. We can get very specific. If we take a look at a roadway, we can use a type of distribution and optic package that's going to get a very wide linear spread without pushing a lot of light forward or backward. So we can spend all of our energy lighting up the roadway and, of course, all of the costs associated for those energy. And that will be minimizing the amount of spillover light on the grass. Unless, of course, we want to have light in a different pattern. So most commonly, we're going to be looking at distribution types. We see type 2, as I was just referencing in the top left, that's on a roadway. In the bottom right, you'll see type 5, where the light is spread evenly, looking down, frontwards, backwards, and side, which is great if you have something in the center of an area that you want to illuminate. Of course, for outdoor lighting with parking lots, we use a lot of type 3 and type 4, which pushes the light forward away from the pole and off to the sides in similar fashion, but in different patterns. And I've run across the question a couple times, what's the very best for parking lots? Should I go with the type 3 or type 4? And to that answer, I always reply with the question, well, what does the project need? Because it's just a matter of choosing the right tool for the job. Here's an example that we had for a facility in plan view. And you can see some buildings in red on the right. There are a couple different portions of parking lots that go around. And to the left side is also the entrance drive. And replacing the previous lumen package that was out there, we decided to go with a 110-watt Lumicon light engine. And across the board, I did a one-for-one replacement with type 4. And you can see we get good coverage, but there are a couple portions here, for example, on the left, where it's pushing more light across the drive onto the surrounding grass. And on the bottom portion, just below the red buildings, the spread is a little short as far as matching up for uniformity. It could have worked, but we had an option to make it more effective. So what I did was reconfigured the situation using different optic packages. Now, these are all the same light engine at 110 watts, all the same housing, they look identical. It's just a matter of the optics package that we used on each fixture to use a different type of distribution and spread. So you can see on the left that with a type 2, the entrance drive really has a nice tight uniformity where the overlap is in a good configuration. We stuck with a type 4 on the very left for entrance drive as cars are coming in and out to have more of a broader illumination. And below the red buildings, again, on that bottom portion, the type 3 doesn't throw quite as far across, but it does get a wider spread, and we're able to match up those peripheries to really smooth out even more what was a good illumination plan. So simply by using optic packages and harnessing and controlling the LED light without having those lumens absorbed by reflectors or a specular surface, we were able to have all the delivered lumens more appropriately placed, which has been a really fantastic advancement as far as getting not only in uniformity, but great aesthetics throughout a project. Here's an issue why uniformity is such a critical staple for recommended lighting practices. particularly those put out by the IES, the Illuminating Engineering Society. So, of course, most of you understand that when light comes into an eye, then you're going to have the pupil in the mechanism is going to open up and dilate to allow more light in. And in brighter conditions, of course, it's going to constrict to filter out excess light. Now, if you have a situation where you have a driver and they're moving through, say, a parking lot, which has wide pole spacing and high intensity lights, you're of course going to have hot spots, if you will. The brightest part is going to be directly under the poles. And in between those pole spacings, it'll be darker. And so as the driver moves, of course, into a dark spot, all of a sudden the eye starts to have to work and constantly make micro adjustments multiple times per second as it moves through an area. Ultimately, that's a distraction, right? Most of the people driving at night, the large majority of them have been up through the daytime. They're already getting into some fatigue. And if you're moving through a parking lot, having an added distraction really gets compounded as far as a safety and security issue. And of course, this is granted talking about a regular pedestrian, but if you have children in a parking lot, you know, below 4 feet, the last thing you want to have is a fatigue and distraction. Everybody needs to be illuminated clearly. So of course, if someone's moving through between the dark spots and the bright spots, and the eye is making, again, all of these large and micro adjustments constantly, that's something we really want to eliminate as much as possible to keep everything safe. So taking a look at how effective that light is being used, not only with uniformity, we're going to take a deeper dive into specifically the color rendering index, color temperature, of what you can expect from LED fixtures. Now, usable light, as I mentioned previously, is all within a range of 400 nanometers in the blue zone up to 700 nanometers, a little more in the red area for light. So that's our second portion, talking about the clarity that you can get from LEDs and the quality of light. For example, a project we had some time ago was here in the middle of Michigan. On the right side was the previous infrastructure of high pressure sodium. A lot of light coming out, but it's all washed out in the same tone. Whereas over on the left side, it's really easy to make distinctions of colors on the front of the building, and in fact, even within the showcase for retail products. For example, putting this slide forward, I have these shapes here with some shading, and you can see the objects. Now, with the same amount of light coming out of your screen, it's not any brighter, but it is significantly easier to identify objects just based on the color rendering index, how much the color is shown true. This is a critical part as far as looking at, you know, not only safety standards and security, but actually having a vitality for example, downtown environments. This is another project that we had some time ago in Michigan, and this is a kind of like a historic district, a very popular tourist spot, and they wanted to replace their lighting. And the caveat was the existing housings they had, the form was also aesthetic they wanted to keep in the historic district, so we had to work with our R&D team at Lumicon to do retrofit kits. They specifically designed light engines to be thermally managed and tested to fit within the existing housings, and of course provide not only an adequate but a spectacular lighting scenario. So starting out, we took light readings out there, and across the sidewalk, they had an average of above 5-foot candles across the entire area, which for a sidewalk is a ton of light because specifically the IES recommends in a downtown streetscape, they want to have 1-foot candle average at a minimum across the sidewalks. So they had a ton of light, which is currently out there, but how effective was it being used? This is just a simple snapshot, and you can see everything brightly lit, but it's really difficult to make distinctions between objects when everything is shrouded in the same type of orange hue. So our team worked, and they developed the light engines, and they got them installed, and we knew what we could expect for not only luminous output, but the energy draw, because the city also wanted to radically cut back on their energy bills. This photo is taken after installation. This is taken from the second-story building on the rooftop, and looking down, you can easily identify the difference between the red and the yellow flowers in the planter on the sill. And the city was absolutely thrilled with the lighting schematic we had done because everything is vibrant. It was much easier to identify objects, pedestrians, retail in the front of the business. And we went through, and as expected, we had an average of above 1 foot candle throughout the entire area, probably closer to 1.6. And in no areas did we get below 1 foot candle. So a couple things with that. One, we certainly exceeded what was recommended by the IES for safety standards for a downtown streetscape. And two, as we had planned, it was lower light levels than what they had out there. But that was not an issue because the effective light that we were being used was definitely a much better option. Nobody complained about light levels being too low after this went in. Across the board, we had a fantastic response. People loved the lighting schematic that we did. So the point of that is yes, you have to have foot candle averages, illumination levels that certainly meet up with zoning ordinances or practices. But just as important is how effective is that light being used? For example, the other one was certainly much brighter, but it was difficult to pick things out. So again, the end users, the municipality, and of course, all of the many customers that came in were really thrilled with the new lighting aspect. Simply put, when you bring color in the situation, we definitely can keep a safe scenario. So what is going to be your best choice for a project? And of course, this will bring to the final portion to confirm to use lighting software, how to predict and make a very informed decision about the absolute best type of luminary you can use for a project for certainly safety standards, aesthetics. And one of the things you want to start out with the question is whoever the manufacturer is, of course, you need to know what are the delivered lumens. Those are the actual amount of light coming out of the ground, not what's being absorbed by reflectors, and the efficacy, the lumens per watt of the fixture. Manufacturer should have an LM79 report. That's where they take the luminaire, pack it up in a box, and take their hands off of it after they send it off to a third-party independent laboratory testing facility, where they will get all of the data of how much light is coming out of that fixture and specifically have all of that recorded. So the efficacy, you can take a look. This is a specific number of lumens per watt. You'll also have the very specific number of how many lumens are coming out of the fixture and, just as important, the wattage. So this is 119.83, and that's all that the fixture will draw. If you have, for example, an old HID fixture of 400 watts, pretty common, they also have a ballast, and that ballast would approximately draw somewhere 40 to 42 watts. That's not recorded on the cut sheet, and so when you're looking at a very specific number on a large scale to get an ROI, you need to know exactly, of course, how many watts you're actually drawing. So all of that data is critical, and of course, this needs to be tested independently. Of course, what they'll do is when they're testing a fixture, they have an integrating sphere which has thousands of sensors all on the inside. And there's a specific document put out by the IES, a 16-page memorandum of the procedures that need to be followed for testing an LED luminaire. One of which, of course, is that they have to turn the fixture on for a specified amount of time before they actually test it. So the heat can stabilize and it can settle in. And then, of course, rather than just a lamp, they have to take the entire unit and put it inside the integrating sphere. You can't just peel off the LEDs themselves because they won't function for very long. So when it's in there and it's operating, all of the light is coming out from the luminaire in, of course, many, many different directions with different intensity for specific directions. And all of that data gets picked up by the sensors and recorded, and there's a specific format for how all of that has to come out in LM63. And this is the very accurate data that reflects how the light operates. Now, of course, the vast majority of people, will just look at numbers. That's not easily interpretable. So we don't have to go through it that way. I mean, it's already 2020. We can just use software and build a model to really render out the entire area. Now, we're proud to use AGI 32. They're a fantastic company that has been leading lighting software for well over 35 years. It's top flight stuff, and it does some excellent work, and it's CAD-based. So it's great if we have projects that have CAD files we can immediately incorporate those in and get a very streamlined approach. But, I mean, let's be realistic. If people are changing over infrastructure of old HID lighting and LED, probably wasn't designed in CAD. We have some old PDFs. A couple times I've actually got to work with actual blueprints, like Wile E. Coyote type stuff, that are out there for electrical drawings. And most commonly, if it's an outdoor lighting project, an address is usually about all we need. We can go on Google Earth with satellite imagery, get specific measurements, also get some dimensions of buildings to really help get things filled out, and then we can just start working from that. And then within the lighting software, we're going to construct a model. We get all of the portions blocked out as far as asphalt surfaces, parking islands, building heights, and all of that gets carefully recorded and built. And then we have to be specific, because if a building is right next to a parking lot we're trying to illuminate, it's going to have a big impact if it's painted white or if it's very dark. And so we have to establish those properties to see how it's going to have an impact on the light that is reflected and bounced back into the illuminated surface. But that's not enough. We have to get really serious, because if we're having a luminaire that has a lifetime that's rated in excess of 10 years, closer to 15 years, there will be some lumen depreciation over that time. It's just the nature of the physical components of solid state technology. It will diminish. And so we're going to look ahead and account for that, say, rather than give you a day one rosy scenario, how is your fixture going to perform 11 years down the road? And we will degrade the luminous output appropriate to that. And then we're also going to be realistic, because dirt components, compounds, are circulating throughout the air. They accumulate on the lenses of fixtures, and with enough dirt buildup, it absolutely will impede the light output of a fixture. Nobody's going to get up on a lift and start power washing area lights in a parking lot. That doesn't happen. So we want to be realistic and say, here's an additional portion that we're going to degrade the light output. And then we're going to fly solo. For example, if we're doing a photometric analysis of a parking lot and it's in an area next to a road and there's a couple businesses around, well, most likely there will be ambient electric lighting coming in. But we're never going to take that into account when we're trying to hit our minimums, because you certainly can't predict the future. If the municipality has some budget cuts and they're not able to maintain the street lighting, or if the business next door goes out of business and they're not able to have parking lot lighting, if you're taking into account that ambient lighting and relying on it to hit your lighting standards, well, that puts everybody in a bad position. So essentially what we're doing is kind of a worst case scenario, which is also very pragmatic. And if that way we design it to hit the lighting standards in that scenario, well, then everybody is protected. So here's what the software does. We have a planar surface, like a asphalt area, and let's say a building next to it. Well, within that space, we'll take a luminaire on a pole, and it will run the calculations to recreate all of the intensity of light that came out of that fixture as it was tested back in that integrating sphere. So for every direction of light, it will reproduce not only that candela value, but also the intensity coming out. And when those particles of light, those photons, hit a surface, it will record the amount of foot candles at that specific spot. And also the software is robust enough to degrade the amount of light as it impacts a physical surface, and of course bounces off and moves through, because it doesn't just stay there, it gets reflected. So over and over, thousands and thousands of times, these particles are hitting a surface, reflecting, and in the process recording those foot candle values. And of course it can hit multiple surfaces. It can hit the ground, back to a building, on and on. It's, again, really robust as far as doing the calculations. So we have the model built, we place our luminaires, we hit the calculate, and we get an iso-illuminance chart that comes out. To most people, this kind of looks like a topographical map. Obviously, we have some shapes and patterns, but what does that actually mean as far as the lighting? So rather than just looking at numbers for the average value, and of course, not to diminish, this is really critical as far as getting very specific, about what your values are. But we can also use the software to put things into a real simple context for the average non-lighting professional to take a quick look and immediately grasp how their project would look when it was lit up. For example, this is a school administration building in Florida. They were looking at a proposal to replace their luminaires one for one on the existing poles and spacing. And so by developing this, we were able to put this in front of decision makers and say, here's what your facility would look like. And of course, we made sure that we were meeting up with recommended practices. But again, the people who are on the decision-making board, the municipalities, were able to look and go, oh, this would be well lit. I know what my project would look like. So it's been really fantastic to have people have a more informed decision. But again, not to skim past it by any means, we always look at what standards we're going to be meeting in every situation. A lot of times there are lighting ordinances. There will be zones or codes that have specific requirements for what they have for lighting. And a lot of times there are not. And so if those aren't readily available, at a very minimum, with every single project, we have a target to go and look for the recommended practices as established by the Illuminating Engineering Society. Now, a point of distinction, they are recommended. They are not a legal requirement, but here's why we go to match those up. Let's say there's a situation in a parking garage where there's an accident and it gets into litigation. Well, certainly one of the first things that's going to happen is a lawyer will come out at night with a light meter and start taking readings of all the light levels. And we'll consult, if there's not an ordinance, at a bare minimum, what the IES recommends for parking garage lighting. And so if we have designed it several years down the road to exceed those recommended practices, well, then it is incredibly difficult, if not impossible, in a court of law to pinpoint the lighting as the source as being culpable for the accident. That's just not the case. So it's not a legal requirement, but it absolutely minimizes liability. Some of those standards we'll take a look at here for a parking lot in RP 20. This also applies to parking garages, as we were talking about. We have a maximum uniformity ratio of 20:1. And this is because people are certainly moving at much slower speeds than they would be on a roadway. But on a roadway, it gets much more specific. Certainly recognize that you are moving at a much different speed in a subdivision as opposed to a collector road through a downtown area or certainly on a freeway. So they break their matrix into different sections. And then once you pick what area, what type of road it's going to be, if it's a major road, for example, you also have to consider how much interaction there will be with pedestrians, people crossing the street. Obviously, with most expressways, should be low to none. But in a downtown area, in a collector, you have intersections, generally pretty high. So that's an establishment that we have to take as far as the lighting. And then from there, we're going to take a look at the pavement classification. Is it concrete? No, that would be R1, and as it's going to be reflective. But if it's asphalt, that would go in the next section. And specifically, they want to know how much aggregate is in that asphalt. If it's a lower amount of aggregate, that would be an R2, but a higher amount of those stone chips and other particles in there actually reflect quite a bit of light. And so that has to be taken into account for the lighting schematic. And then right after that, as I mentioned previously, just as important as everything else, given the same weighted criteria, is that uniformity ratio. So if we're looking at major roads, for example, with a high conflict, you'll see 3.0. And it's the average to minimum requirement. What that means is the average of that entire roadway can be no more than 3 times as bright as the very lowest single point that's recorded in that area, which is a strict requirement. Again, this goes back to recognizing that as people move through a space, a smooth, uniform illumination definitely has a strong advantage for safety. But it's not just roadways as well. We get very specific about how an environment is broken down according to its use. For example, a gymnasium, a high school, will require 50-foot candles on the surface. If it's college, they require 75-foot candles. And if they're broadcasting on television, they want 150-foot candles out there. So we have to adjust for the use. Another point as well is inside of an office space. This is a project we looked at, and the requirement was 40 foot candles on a desk surface. And even back in 1940s, the IES recommended 40 foot candles on a desk surface. But in the 1960s, they had adjusted that and required 100 foot candles on a desk surface. For most people, that sounds like a lot. That's personally my preference. But currently, the IES recommends 40 foot candles a unit. And I think there are probably two reasons to that. One is technology. Not only is there more of an emphasis on task lighting, but realistically, the majority of people in an office situation are working on computers and laptops and monitors that are self-illuminated. That's its own source of illumination. So you just don't require 100 foot candles to be able to see clearly what you're doing. And the other point too is that honestly, it's just simply subjective. So talking about a lot of the numbers today, clearly lighting is very much a science, but it is also an art, because at the end of the day, we're talking about how an individual, a human being, perceives an environment. And there are trends and tastes and subjective preferences that come into that play. And so throughout that, the IES is continually assessing, reassessing, and advancing how they have their interpretation of what is the current accepted levels. And this is not something that is done, every decade or so. They're consistently moving through all sorts of inputs. Here's a project that we had. A municipality had several existing fixtures of decorative post-top acorn luminaires. They had wall packs. They had some floodlights, bollards, and they even had some specific type of custom lighting for their clock tower. They were looking for a single manufacturer in the U.S. to be able to go through and replace their entirety of their outdoor lighting catalog at a 1-for-1 ratio and match the same type of lighting levels. So we were able with the software to go through, not only see what they had for a recommendation, but specifically to be able to get in front of those decision makers and say, this is what your courthouse, your facility would look like illuminated. And with having that capability with the software, they decided to go with it, and this is what it looks like installed today. And as I was working on this with the director of facilities, he asked me, what have you got to replace a 400-watt luminaire? And as I mentioned earlier, my answer is always the question, what does the project need? Because when this building was first established decades ago, there wasn't a big difference in the cost between a 250-watt or a 400-watt HID flood. And most importantly, the energy costs were nowhere near what they are currently. And so simply a contractor would just slap in a 400-watt, call it good, and not have to worry about it. But as we were taking the time to go through and really assess what the facility needed, I had gone through a proposal, and this is the LED fixture as it's installed today. Now clearly, this is plenty of light, and wall washers are doing their job quite effectively. And those LED fixtures out there are drawing 70 watts. I want to make a point of distinction. The efficacy years ago when this was put in, a 70-watt LED was not equivalent to the luminous output of a 400-watt HID. But that's my point. It didn't need to be. They simply had just put in more light than they needed, and rather than going just bare bones, we were able to scale it back, assess what the project needed specifically, install it, and make it look great. So again, everything can be looked at through the prism of simply just doing an off-the-shelf quick cut, or we can take the time to really assess what a customer needs, what is best serving the project as far as the energy usage, the security standards, and also the aesthetics, and how to make an entire project to the best ability. Of course, Lumicon has always been offering this service as far as any type of project with no cost. That's just a service we provide to look at any type of facility, and there's not a commitment either. There's not a requirement. This is just something we do upfront for a study to see what's going to be the best type of application. So I definitely am grateful that everyone took the time to log in today. I really appreciate your attendance. That's going to wrap up our portion for the photometry presentation. And along as I mentioned previously on the side, I do have the chat bar. So if you have some specific questions, or even general questions, go ahead and type those in. And again, if you don't have a specific question now, it's not your last chance. You can always feel free to give us a call at our office. We are proudly located in Farmington Hills, Michigan, just adjacent to the mighty city of Detroit, where we proudly do all of our design and manufacturing. And on that website as well, www.lumcon.com, in the staff, my name, Michael Woznicki, is there with my email address. And you can individually ask me about any type of project you have. Got a comment there? Thank you. Thanks for taking the time to log in today. Appreciate that. I saw a question there previously, but I wasn't able to read the entirety of it. David, thank you. Appreciate that. I did see that question already posted previously about designing roads, but I didn't get the entirety of the question. So if we're not able to get that up in the next minute, please give me an email or a call.
Michael, it says, design the roads. It is not possible to simulate the whole building all in the road. So what is your suggestion about that?
Let me clarify. Not possible to simulate the whole building all in the road.
Let me resend.
Mm-hmm.
Can you read it now?
Let's take a look. No, it's not popping up. Well, I do apologize. Typically when we run webinars, I will be over at the headquarters, but obviously we've got some different circumstances these days of presenting my residents.
So basically what I think he's trying to say is that when you design a road, it's really not possible to simulate all the buildings that are going to be on that road. So what is your suggestion about that?
Oh, okay. Great. What we'll typically do is, depending on the portion of the roadway, so if it's a long stretch of road, very typically they will have a kind of a standard pole spacing, for example. And so from that, we will get a long roadway, and we'll take a portion that is most indicative or representative of the length of that roadway and then design to those standards. And then also, not just leave it there, but take an assessment and say, okay, where are there going to be more driveways coming in that will disrupt that pole spacing, take those into account, and possibly have other smaller subsections in those worst case scenarios to see how that's affected and impacted. And for adjacent buildings, depending on the size of the project, actually don't need the entire of the building. The most important part is going to be the front-facing portion of the building. So we can just have a simple planar surface, you know, whether it's 12 or 40 feet high, that's going to impact the light reflectivity onto that surface. And, you know, beyond maybe 20 feet or so, we don't have to really get in. So I see your reply, and hopefully that answers your question. But also, Bob had posted my email, and if that doesn't answer specifically, I'm glad to continue this after the presentation. Much appreciated, Ollie. Thank you.